going to help if I unmute. I'm not sure who all will be joining us today. Let me just log in over here. Just going to log into chat real quick. Okay, I think we're live. And I'll just be monitoring chat in another window here. Today, I thought we might go through a bit of code that I recently released on GitLab. So it's not technically fresh live coding, but I'll kind of show you how to use it. And then we will wrap it up there, unless we have any submitted issues. Okay, so let's share here. Oh, shared the wrong screen, 1 second. There we go. All right, so one of the things I've been working on for quite a while, but recently got a lot more priority, is a AWS runner template for GitLab runner. So we frequently get questions about how to run GitLab on AWS. And sometimes it's customers who are self-hosted on AWS. They have to run runners on AWS. And sometimes it's customers who are actually a .com customer. Their primary cloud is AWS, and they want to extend or expand their runners into AWS. A couple of reasons why you might do that. One would be that you are using the runners as a security proxy. So you put them in the actual target deployment environments and put an IAM profile on the runner. And then any code you send there will have permissions to be able to do whatever you need to do within that cloud. So that is one use case or scenario that is common. Another one is just trying to get specialized runner workloads. Maybe you want to run your own to offset costs. A lot of times there's security concerns about where your code is being processed. So there's a variety of reasons why you might come up with, well, I need to build my own runner. If you're on GitLab.com SaaS, of course, you don't have to set up any part of GitLab. So as soon as you go to set up runners, this is the first time you may have had to play with, how do I instrument getting GitLab runners set up on Amazon? Now, our documentation does have guidelines. So I'll just do GitLab runner on AWS documentation. Take a peek at this. This one's called Auto Scaling Runner on GitLab on AWS ECS. Now, this was put together quite a while ago, and it uses the Docker machine executor. And Docker machine is how it scales. So it doesn't actually use AWS native scaling. It just scales based on the runner is running on a Docker machine and can then launch individual machines to satisfy demand. Well, Docker machine has been deprecated by Docker. And so GitLab is also deprecating the runner based on it and looking for different ways to start to handle scaling capabilities. And so one line of inquiry or thought is to look at native cloud scaling on the major clouds. And so that's one issue here. The other issue is, if you follow this guide, the actual Docker machine, it's never recommended you put it into an auto scaling group. And of course, you shouldn't auto scale that Docker machine runner because it is your scaling appliance. However, by not being an auto scaling group, that is also a single point of failure. So it won't reestablish itself if it terminates. And so that's, even if you are going to use Docker machine for a while or are currently on it, that is one hole that this new approach can plug, because you can run it in a non-scaling mode and be able to regain that capability to have it be warm HA. So if it terminates, it reestablishes itself without anyone's interaction. Now, I call this the GitLab High Availability Scaling Runner Vending Machine for AWS. So let's unpack that title. I have a tendency to overload my titles. It's not uncommon in technology, but it is a GitLab runner that has high availability and scaling. You can use both or just high availability if you don't need to actually auto scale. In Amazon, both auto scaling and high availability of something like the runner come with the same appliance. We use an auto scaling group that simply doesn't do any scaling in order to do the high availability. It's a vending machine in that it's designed to be something that you can run again and again in order to have a variety of one second here, I got someone. Oh, 1 second. So as I was saying, you can set up a variety of these. Now, you may very likely want to set them up by certain workloads or operating systems or runner executors. Right here at the top, we mentioned it's got elastic scaling, so that'd be up and down, spot support, and Windows support. So the whole thing has got equal parity support for Windows. And if you're a Windows shop, one of the challenges is if you're doing .NET Framework, you're probably going to have to do that on a shell runner. And if you're using a shell runner, then scaling them automatically is not something that's easy to achieve. So this will bring that scaling capability to you. Some other things that should be noted. It's self-service, so you can actually give this to your developers and have them be able to deploy runners on their own as long as they can run CloudFormation. They are able to specify their own IAM profile, which would then cause them to be able to use the IAM profile that they use for development for the runner. So that's kind of a unique aspect, is kind of some self-service automation in there. And the approach follows some specific design heuristics. So GitLab has the concept of using boring technology. So in this case, we are purposely using boring technology on the AWS side. And then it uses Amazon Linux 2. There's a justification here for why you might really want to stick with Amazon Linux 2 when deploying this kind of compute to the Amazon cloud. And we also talk some about instance types. So I'm not a fan of T2, T3s, especially anytime you're doing, like, if you're actually using this for auto scaling, these bursty instance types will give you false signals for auto scaling because they're going to like run out of compute, or they're going to be super network constrained, or something else that is not a real thing. It's just an aspect of the fact they're bursty to keep costs lower. So I would say that you want to choose an M5 class or later. That puts you into the Nitro class of Amazon instances. And then it also gives you MVNE storage drivers, which are fast, or ENA network drivers, which allow you to have ENA much higher bandwidth on the network, either in burst mode or guaranteed mode. And then they're also automatically EBS optimized, which means talking to disk and network are done in separate channels, where when you don't have EBS optimization, those conversations hit the same channel. And then also, when using Docker on Amazon Linux 2, because it uses a newer Linux kernel, you get to use the overlay 2 driver for Docker, which speeds up Docker operations for all the intensive layers of virtual disk that it keeps in order to do the magic of Docker. So to run this in CloudFormation, you can just load the CloudFormation template that's a part of this, and we'll do that in just a minute. There's some other features. You can start and stop the entire ASG with specifying a schedule. Now, in real ASGs, you can put 10 schedules on there. We expose 2, a start and a stop, with the idea that if the team who uses this is on, only does 10 hours out of 24 in 5 days a week, then you can have the runner completely off at other times. So that also relieves the issue if you're using a nicer sized instance like an M5. Well, if it's off a huge portion of the time, then it's not as much of a cost concern, and you can have a proper machine speed when it is up and running. Another interesting aspect of the implementation is the runner configs directory. So 4 are provided and they've been tested, but you can easily take one of the 4 and start innovating forward. So if you want to use Ubuntu for, say, Linux runners, or you want to do one that has a special configuration for Windows, you could take what's there and start innovating forward. And then we just talk a little bit about that restoring HA to Docker machine if you're going to continue to use it. So we have 4 provided types of scripts, and they are for Docker and Shell, and on Windows and Linux. On Windows, there's actually 2 kinds of Docker drivers, one that does Windows containers on Docker, and one that would do Linux containers on Windows, on top of Windows. In Windows, you can't do both of those on the same host. And the reason why you might want to run Linux containers on Windows is, say your organization has a requirement that all infrastructure at the instance level is Windows. Well, then you could still fire up Linux Docker containers. And that can be important in GitLab because most of our security scanning uses Linux containers. So even if you're a pure Windows shop, you might want to be able to get that going. This represents a CI YAML that does hello world across all 4 of the types. And this represents my testing showing that job running successfully. And this shows what the original setup was for the runners that were in that test group. So you can see there's both Linux and Windows, Shell and Docker. You can also see this interesting and important piece is that the compute type, whether it's spot or on demand, bubbles right up to the runner. And that's important because you may or may not be comfortable running certain workloads on Spot. If you're going to, I actually encourage you not to write off Spot too quick. Some people hear that, oh, it can get terminated and they get really nervous. If you go look at Amazon's Spot page, even with standard pricing model, there is very low termination rates, like less than 5%. But then there's also a new scheduling method that we expose in the template called capacity optimized, which means you pay a little bit more to lower those terminations even further. So just keep that in mind. If before you go and write off Spot really quickly, you want to think about that. But however, you should be putting your workloads on Spot or non-Spot intentionally. So some loads like ML Ops, which is an increasing request, and it is a use case that's in view for this. And also workloads like mass testing. You might be able to lose a node or two, and it doesn't really matter. The system will continue to run all the tests till they're all complete. And there's also some GitLab CI settings to detect when a runner completely fails or dies and restart the job, retry the job. So because of all of that, you might want to send certain loads to Spot and certain loads reserved for on-demand. There is one link in here that's important, the testing and troubleshooting guide. So if you haven't had the good pleasure of debugging infrastructure as code, it can be pretty challenging because it takes so long to run an end-to-end test. And then once you run an end-to-end test and have a failure at the instance level, it can be hard to debug. Well, this template is designed to help with that. It automatically installs the SSM agent if you simply leave one of the parameters at default, and then you can SSH to the instances without any setting up SSH, without setting up gateways and keys and users and all that. You will do it through the console. We also go through all the log files, both the ones that are built into CloudFormation, as well as special ones that are special to this template. We also show you where they are for Windows. And then importantly for Windows, we have this little bit of a guide for those of you who are coming from the Linux world, three or four key things. So basically, catting files is the same because there's an alias in Windows PowerShell. There is no console text editor in Windows, so you can quickly install one via Chocolatey by doing this one-liner. It will detect if Chocolatey's there, and if not, install it, and then install the Chocolatey package for Nano. And then finally, this little function, if you register it into your console, will let you tail the Windows logs. So there are still a lot of text logs in Windows, but the actual event logs that you're familiar with in Windows are in special databases, so they're not accessible through text commands. So I came up with this one-liner so that you can kind of treat them as if they are. Most importantly, you can tail those logs so that when you're testing termination, if the termination is working correctly, the termination hook and the ASG, that you can see whether it was processed or not. And then finally, for both OSs, we had to implement CloudWatch metrics so that we can get metrics like how much memory is available. It gathers a lot of other metrics, ran the wizard for the advanced metrics for CloudWatch on both operating systems. And these are reporting up to CloudWatch, and they also aggregate by auto-scaling group. Very important for setting alarms against any of those metrics. Also, they are being, the dimensions of the instance type are being reported. And the way that helps you is you can start seeing that maybe your workload doesn't work so well on a general purpose type. It's running out of memory all the time, or it's running high CPU utilization, and you can then use a CPU oriented instance type and rerun your test and figure out that, oh, it won't scale as big if I simply use a slightly more expensive CPU intensive item. I might end up, or instance type, I might end up actually lowering my overall cost. So there's some helpful things in there. If you're going to really hyper tune something that say has to hyperscale from ML Ops, if you think about it, no matter what technology you used, you have to develop site reliability engineering skills for that hyperscaling. So one of the cool things about using this is you're developing them with GitLab, or Amazon ASGs, something that you can use again and again. So that hyperscaling sensitivity that you can figure out, this ML Ops workload has a certain signature, and if we use a certain instance type, we get the lowest overall cost and the reasonable scaling responses. So I'm going to log in to Amazon. 1 second here. Take this off screen, even though it is obfuscated. I have one of those really long passwords that is so crazy long, it's very easy to miss it. My goodness, it's a bad day. Okay, so we're going to go to AWS. And I have, like a good security citizen, I also have MFA set up for all of my Amazon accounts. Okay, so we're going to head over to CloudFormation console. You'll see I have run this and some other things several times. I'm going to say create stack. And I'm going to choose back in our repository, there is this file here. Now I've already done a local clone of this repository, so I'm going to pull it from a local file. And when I take the next, click next, this has been purposely designed to give you lots of help in the parameter text. So CloudFormation templates can be loaded interactively like this, and they create a form. And once you figure out the parameters you want to use, you can then use a CLI to run the Amazon CLI to run CloudFormation without having a form. You can also use parameters inside of files, so you could actually code the parameters into a file and not have to key them out or have great big long command lines. So we're just going to say ASG runner Linux Docker 1000. And right here, one unfortunate thing is the overall metadata for the template does not display in here. So I've had to do this, just reminding you that all your characters have to be lowercase up here. And this is because most of you are probably going to let it create a bucket for you. And buckets have to have all lowercase characters. And it uses a stack name when it creates one. And there's not a simple way to either check whether you have used uppercase letters in your stack name or to make it lowercase for just the bucket part. So got this cheesy message, just say, hey, make sure you have that. Here's the version number, also just a parameter that you can't actually change, and where to kind of a README, where's the source project. So we're going to leave this at Linux. You can also choose Windows. The patch run date, it's not doing any date arithmetic here. What it's going to do is simply embed this date as an environment variable in the instance, expose it as a EC2 tag. Why it's there is if you go to, once this is set up, it's got maintenance built in, so you can come back in and say, change the patch date. You could actually change it to any text. You could change it to XYZ. But the way CloudFormation works is because we use that parameter inside the user data, it says, oh, I've got to replace all the instances. And so it's really just a trick to give kind of a human readable, when's the last time I ran patching on the ASG, as well as to trigger that effect so that everything gets replaced. So we could put today's date if we felt like it, January 29th. Maybe I should make it the release date of each release. That would be fun. Then a patching scope, and this works for Windows and Linux. You can do all patches that are outstanding, security only, or no patching if you're just doing debugging. So I'm going to pick no patching so that this will move along a little faster. Both OSs also have reboot detection. So once they get through the patching cycle, they don't just reboot, but they check, do I need to reboot? And if they do, then they reboot. Linux used to terminate in an ASG when you do this, but the template also implements something called auto-scaling groups, hooks or lifecycle hooks. And one of the ones it implements is launching. So because of that, it'll reboot, no problem, because it hasn't told the ASG that that instance is in service yet. So that helps you with patching. There are a couple scenarios. If you look right here, we can always use the latest AMI. If you're using an old distro, like Amazon Linux 1 or Classic, or you're using an old version of Windows, then if you peg that AMI here, it's going to be important to apply the patches. So patching up will be important. If you're using Amazon Linux 2, which right now is released very frequently, then a lot of times you're getting a very recent version just by using the latest AMI. This is explained in the template, but if you always use latest here, there is a parameter at the bottom that uses the SSM parameter store to look up the latest AWS prepared image for the distro of your choice. Now we only put Amazon Linux 2 as the default here, and then we also give you the Windows defaults for the container-based Windows that Amazon prepares. You can look up what these parameters are. So right here's an example of how to look up, in this case, what are all the Windows ones. You can change this though, so that you can look up all the Amazon Linux ones, all the Ubuntu ones, whatever you want, and then you can find out what that parameter is to grab that latest AWS prepared version of the AMI. You should always start with Amazon ones. In the case of this stack, we're going to build the runner onto it dynamically. But even if you have to create say an Ubuntu image with a custom prep, you should start your Ubuntu image with Amazon's Ubuntu, which is optimized, probably has those drivers I talked about earlier pre-installed, might even have SSM agent pre-installed. So you're going to want to start there, build on top of it, then burn your AMI, then you use your AMI here. So just keep that in mind, that the Amazon prepared ones have a lot of advantages over starting from scratch. How many GitLab runner concurrent jobs, whether it's a shell or a container runner, how many jobs do you want to run at once? Then your GitLab instance URL, and this can be gitlab.com if you want it to be. I'm going to leave it at this setting. Then your runner token list. So I still have to fix up Linux, but right now Windows will take more than one runner token, runner registration token. And that would let you register, say, to 2 or 3 different group levels without them having to be in hierarchy, or just to specific projects without them having to have a hierarchical relationship. You can also just register a group runner token to get the runner attached to everything in that downbound hierarchy. So there's a whole bunch of ways to do this, and that's why it can take a list in case you have to connect it in more than one spot. Also, keep in mind that the runner registration token is just authorization to create a runner token. So the runner token is what the runner uses ongoing in operations to maintain its secure connection to GitLab, to your GitLab instance. The runner registration token is simply the initial authorization to be allowed to make that connection. So you don't want to confuse runner registration tokens with runner tokens that are the ongoing authentication. We can also add arbitrary tags. Right now, the Linux Docker runner is the only one that will run untagged jobs by default. You'd have to edit the scripts to get the others to do that. But the other ones all require tags because they're usually the special case. So if you want to use a Linux shell runner or any Windows runner, you usually want to use tags to route it there. However, those tags for the operating system will be put on for you, and the executor will be put on automatically. This is for you to arbitrarily say team A or whatever you might want to identify this runner for, that it gets selected by tags. You can also leave it blank if you don't have any specific reason to give it tags above and beyond what it'll create by itself. The GitLab runner version, so you can either peg to a version or you can use latest. It tells you here in the help how to find the list of possible ones you could use here. And this works for Windows and Linux as well. Then the configuration scripts that we have available to us. If you remember over here in the testing and troubleshoot, no, it was in the bottom of this guy here. We tell you what the script names are. So if you wanted a different one, you would change the end here. There's not validation that your OS matches your AMI, because especially if you just give us an AMI ID, we have no idea what OS is in there. But even if you use a parameter, it would be really complicated logic to be able to say, oops, I think you're using a Linux shell script with a Windows host or vice versa. So make sure that you get this right, or else you'll have an unusual failure. And if you have a failure where the script seems to not run at all, then you want to go back to your CloudFormation parameters and check if you messed this guy up. Not that I've not done it like 100 times already, but I have. Installing code deploy is optional. That would be a way to get code pushed to these instances without cycling them if you wanted to. In most cases, you probably won't need to use that. Desired capacity, this is how many to fire up initially. And then it always has a required minimum capacity of 1. This is one way to test scaling. If you set this to 5 and immediately upon build, you said maybe you say CPU level of 30% is when we'll scale down. You fire up an ASG with 7 of them and it goes, CPU has been sitting at 10% for 60 minutes. Let me kill one. Oh, another 60 minutes. It's still sitting at 10%. It will just kill them all until it has only 1. So this is also a simple way to test scaling down. To test scaling up, you have to generate some load. This is the schedule. So you add the schedule simply by picking a start and stop cron mask. You don't have to use both. So you can make it so it just shuts down or just restarts. Maybe you have people manually shutting them down when they're done and you want them to automatically start at a certain period of time. Or you have ones that are only used for deploy. And so you do deploys on the weekend and you want to make sure this runner doesn't run forever. So you set it to terminate Monday night, late Monday night or something. And you know that by that time it'll be unused. And then people can manually start it before deploy. So you can use this for a lot of different things. How many instances to launch on the schedule start? So maybe this is a scaled runner and once it starts, it should start with more than 1 instance right away. Or maybe it's not auto scaling at all. So you want to start it with the same number as what you start up here. This is only used for updates. So if you come back into CloudFormation console and do an update, this is the methodologies that are available within CloudFormation. I'll let you read about how those work and you can decide on which one you would need. Auto scaling enabled. So we can set this to true or false. The reason you set it to false is you still get a lot of benefits, mainly warm or hot HA. If you have 1 or 2 instances in ASG and one of them dies, it'll respawn a new one for you. And so if you have long running runners, it's surprising over time, you'll start to get some of them get fouled up and they terminate. So this is one way to protect yourself and have HA even if you're not scaling. If you set scaling to true, then these auto scaling parameters are all then in play. So one of them is the maximum size we'll scale to. Another one is whether we'll scale on memory or CPU. So we can scale on either of these metrics. I have not done a lot of testing on the memory scaling yet. CPU is working pretty cleanly, and I'm pretty sure that the memory scaling on Windows is not working correctly yet. Then your scale-in threshold. So what percentage of utilization of whatever you have here do you want it to scale down? So we'll say 20%. So for if you have 5 machines and the overall utilization across all of them is less than 20%, then let's drop a machine and keep doing that until we get to the minimum. And then how long does it have to be at that CPU utilization? A minute is a fairly common choice. You can make it longer if you have the freedom to scale slower. Scale out utilization, let's say 70% CPU for 60 seconds. Here with the bucket name, the bucket is just a bucket that will automatically be given permissions to the instance profile that's created. If you're going to do code deploy to these instances, that would be one reason. Also, if you're going to do caching for the cluster runner caching, then that would be another reason to create a bucket so that there's a bucket that every instance in the cluster has access to. So if you leave it at create one form, it'll create a bucket for you and permission it for you properly. This whole template also uses the principle of least config, which means If you don't want something, it's not going to create it. So if we had said auto scaling false, it doesn't create auto scaling alarms. It doesn't create auto scaling thresholds, or metrics. So it's going to be smart enough to say, if you're not using something, we're not even going to set it up. Self-monitoring termination interval. So the instance is going to monitor if it's being terminated and then run GitLab unregister on the runners. I also have, as a task to handle very soon, is running sort of the best shutdown. So kind of draining the jobs that are on the instance to the best possible scenario that we can. So that's what this is about. So the termination lifecycle hooks allow us to do stuff like proper shutdown. And if you didn't have this and you scale your runners back and forth, you're going to get a whole bunch of dead runners, runner registration tokens in your console, and it's going to be confusing to figure out what's live and what's not. So this is an important part of the puzzle, is that when runners are scaled in, we go ahead and deregister them on the way out. Also, if you are doing spot, you have a 2-minute warning before you're terminated, and that's why the default here is 1. If you're not using spot, then you can make it longer, but just keep that in mind. And then you pick your instances up to 4. CloudFormation actually supports up to 8. I thought 4 was sufficient for runners. You could customize it if you need more. One interesting thing too is even if you're not scaling or not using spot, this also provides the ability to shift instances. So one thing that can happen is you can request, say, an M5 large in the US East region 1 in your account, and AWS responds with an error. I literally have no M5 larges left in that region. And if you don't have anything else going, your automation fails. But if you provide it like this, even though you're not doing spot, it will then start going down this list to see if it can find an instance type that is available in that region. So this protects you against what's called instance type exhaustion in a given region. Also, if you're going to use spot, if you're using a fresh Amazon account, it comes with 0 spot instances available across the board. So if you want to use spot and you're getting failures, check that you have at least some spot instances quota available. So on a brand new account, you'll have to go in and say, I would like to increase my quota of spot instances available. Try to increase it by something small like 2 or 5. So you can test with it, but just keep that in mind. And that's why also I tend to default this, or I tend to work with this with non-spot if I know the account does not have it yet. These are Amazon's terms, so on-demand base capacity and on-demand percentage above base capacity. So it's basically saying how many non-spot instances do you want to start by default? So of the total that will be started, do you want to start 1 non-spot? So Amazon allows within one single ASG the ability to have spot and non-spot instances. Because this template surfaces that information from the individual instances, you can have one ASG that has some of both, and then that way you don't have to have separate ASGs. So this one's 100% spot, this one's 100% on demand, which saves you money because you don't have to have it separated by those concerns. If you want 100% spot for a given ASG, say all it does is run test workloads or MLOps, then you would set it up this way: 0 on-demand base capacity and 100%, or no, I'm sorry, this will do 100. You do 0 here too. So if I do 0 here, this will be all spot. 100 here will do all on-demand. And you don't necessarily have to have any even initial on-demand capacity. If you set it to 100 here, though, because we said we want 2 instances above, it will start 2 on-demand instances. Apologies if you find this confusing, but I did stick directly with Amazon's nomenclature on how to think about this. They could have used opposing terminology and said, how much spot do you want? But this is the terminology that's actually used in the Amazon literature. So I stuck with that so that when you're reading about it, you don't have to translate those concerns when using this capability. Here's that spot allocation strategy. By default, it's lowest price. which still has very low termination rate, usually below 5% for any given instance type. But if you select capacity optimized, it's going to be even lower. And there's information here if you want to look it up. You can configure a key pair so that you can SSH to the instance. I would strongly encourage you to modernize your practices if you're still doing this and use SSM Session Manager. SSM Session Manager does not have to have any open ports or anything. You can do it straight from the console. Some people don't realize, though, that you can also, with an AWS CLI installed or CLI installed on your local machine, you can go in and do an SSM Session Manager extension to that CLI and be able to do your normal workstation, what appears to be SSH, 2 instances in Amazon with no routes, no internet gateways. It all goes through the Amazon hypervisor level. So that's a much better way to do it. And the way you configure this for that is just put true here. You can do both. And there is, if you do have a key pair name, the ability to do a console in the Amazon web console is also enabled by a key pair. But just getting rid of the whole key pairs thing and the issue with managing them and all of that can be a big plus. When you do troubleshooting mode, it's going to install the SSM agent, but it's also going to extend the IAM permissions of the instance so that you can indeed SSH or SSM Session Manager to it. Right now, you should not use this. It works. It's a CPU utilization driver. It uses stressng on Linux, and then I forget I had to find something else for Windows. The problem is that it's not yet designed to run in the background, so it stops CloudFormation from completing properly. So you can play with it for about an hour till CloudFormation goes, I still don't have enough instances, so I'm going to terminate and roll back. If you read about this in here too, you can also self-terminate it. So what this does is it sets a CPU utilization for the cluster to start at. So let's say we set it at 95. The cluster would fire up and all instances would immediately start going to 95% utilization. You can then go into SSM Parameter Manager because this will create an SSM parameter, and you can say, and you can watch the ASG scale up. Every time it scales up, each new instance immediately goes to 95% utilization, so it just starts scaling. And you can see how quickly and smoothly it scales, and if you don't like it, you can make adjustments. It also uses step scaling, which means if we're driving that percentage for an extended period, the longer we drive it, the quicker we start starting up instances. So we don't have this typical problem of scaling being too latent. So this template also uses step scaling. You can then go into the parameter manager and say, hey, now run it at 20%. If you got like, say, 50 instances at that point running, they'll all go down to 20%, and then it'll start down scaling according to your scale in parameters. I'm going to try to fix this, so that it works in the background. Oh, and one other thing is you put any text value into the parameter, it immediately terminates this. So you can actually use it to stand up a production system, test it and say, hey, I like it, it's good, I want to keep it. And you can just go in and say stop in that parameter instead of a number, and it will terminate the CPU stressing utility. So I'm going to see about getting this working. I'm maybe going to see about if I can get it stressing memory. I've been having challenges stressing memory with the way that Amazon memory metrics are reported. But we'll see about getting this working for whatever metrics you're using. A quick note about scaling metrics for those of you who are familiar with Amazon scaling. We could create a whole bunch of scale in and scale out metrics that have to do with both CPU and memory and all kinds of combinations. Now, obviously, to get the information of what that should look like for your specific situation requires a lot of work. And I didn't want to make the template so complicated with so many options. So right now you have one scale in alarm, one scale out alarm, and it's based on one metric, either memory or CPU. We may also extend this with some GitLab metrics. Some people want to do it by the queue length. I'm not really all that in favor of that because there's nothing about a queue length that actually predicts what loading there will be on the ASG. So if I send a whole bunch of tiny jobs that take 5 seconds to run, and then I start scaling the cluster based on that, I'm going to be wasting a lot of compute. So in theory, we should be able to find metrics that are based on what the machines are actually load that they're actually under to control scaling. And that's why initially here it's focused on regular old machine metrics. This is the SSM parameter we mentioned earlier, that if you're saying always use the latest AMI, then it will use this parameter to look up the latest AMI. Finally, the IAM role name. So if you let it create one for you, it'll create the minimum viable IAM role for this all to work properly. It also creates the actual permissions as managed permissions, so that you can go in and see what they look like, because you might already have IAM roles, say for your developers, that you use to do all your Amazon stuff. So you're not going to want to necessarily use the simple ones that come with this. So you're going to want to use those ones, but you'll need to extend them with at least the permissions that are in here, so that we can do stuff like read that SSM parameter. We can write logs to CloudWatch. We can do SSM Session Manager into these instances. So it sets them up and you can go look at them or look at them in the CloudFormation to see what they are. Now I'm just going to quickly look back here and see if this is ready to go. I need my token. I'm gonna pop that in there separately. Or actually, what I'm going to do is I will cycle the token. I have a test group that a test project that only has one single thing in it. So it's not really a big deal if you see it, and then I cycle it after this video is cranked out. Interesting. 1 second here. To start up another browser. Okay. Okay, so I'm going to go to my test group. Just has that hello world YAML in it that I showed you before. Whether you're in a group or in a project, you go into settings, CI/CD, and under runners, we take a look at what runners are configured. So I already have some set up here, but then here's my runner token. So I'm going to copy it. And then I'm going to paste it right here. Let's look over this other stuff. Going to make sure that I'm doing Linux Docker. That's what I want. In the case of Amazon Linux, Docker is installed for you. In the case of Windows, you're going to want to use one of the ECS or a container prepared images by Microsoft. And part of that is it takes a while to install Docker and a reboot for Windows. That would all happen, and we do the reboot detection and be able to reboot it for you. But it's going to save some time if you just boot the one that Amazon prepared. So I think this is ready to go. Let's see what happens. Step through each of these. We are going to create IAM resources, so we check here. We hit create stack. Oh, yeah, I did hit it. It's just taking a little bit. So this is going to process, and we'll go to some completed ones to take a look at what it looks like. So here's Windows Docker. You can see the events that processed, the resources that were created, and we can see, I mentioned how some of the policies are created as managed policy objects so that you can examine them and rip them off, so to speak. They are ASG specific, so this is also running least priv. So when this spins up, the instances need access to certain information about the ASG itself to check if they're terminating, and to their own tags, so they can write their own tags and stuff like that. So that's what these policies are about, but they are focused on or limited to the ASG. And so what that does is makes it so that stuff running on these runners can't reach out to your other AWS stuff. And that's the best way you would want to do it too. So keep that in mind. And that's another positive of using this template is it's going to be least priv for the auto scaling group, and you don't have to worry about cross usage of your stuff. So I don't know if this will finish in time. Let's just see how quickly it's moving along. What we can do is take a quick look at a completed one. So right here we have available, here are the tags. I left the tag AB on here. Notice here, if we told it to have some sort of schedule, it puts that as a tag. And the reason is it's going to be frustrating for administrators to come in and be constantly like, well, my goodness, why is this off again? And they're not going to know why. And so ones that have a schedule applied show that they do. And that's whether or not they have a startup, only a startup or only a shutdown or both defined. It just says, hey, there's some schedules involved here. We also can see the compute type. We can see the GitLab executor type and the operating system type. Also, for manageability over in the AWS console, when we go to look at instances, the tagging there is also done similarly. And the simple reason for this is I've worked in organizations where we had like over 300 runner ASGs, and it can actually be hard to figure out who built this runner, what account did they build it in, and where is it if I want to go, where is it in Amazon if I want to go debug it. And so what we do with the tags here is bubble up things like what GitLab instance is it registered against, what are the exact GitLab runner tags I should see over in GitLab. And then there's the patch run date I mentioned to you and the compute type. The rest of these are pretty much automatically created by Amazon. But it helps you connect runners in the console to runners in your environment. Okay. So let's okay, so are we done completely now? So this was Linux Docker 1000. And oops, if we go in here, it's still creating. So we do still have some things going on. Most likely the auto scaling group is still spinning up. Yeah, so it's still trying to create the instances for the auto scaling group. So we're almost at time. One other thing I can show you is if we go into the repository here. This is not the right repository. What did I do with that guy? Let me just see my list here. So we can go into this repository, and in pipelines, we'll force a pipeline. It will, I don't have every runner type going, so some of the jobs will fail because there's not a runner to back them. So you can see these two start right away. These two, there's no runner matching those tags, so they'll eventually fail. But you can see that the various runner types go ahead and process. So that's a summary of what this particular guided exploration will buy you in terms of starting to get a handle on your scaled AWS runners. Even if they're not scaled, just the self-service aspect alone is helpful, and the high availability aspect is helpful because you're basically following Amazon's well-architected principles that any kind of instance compute should be in an auto-scaling group in order to reestablish itself. There's no charge for auto-scaling groups in Amazon, by the way, just the instance compute that they end up driving. So it's a free capability to create scaling and high availability for you. So I hope this has been helpful, and look forward to seeing you next time we do live coding.